Hello again. In this final video on Modulus, we're going to look at sketching. Sketching modulus functions. Cool. Okay. So let's have a look at this. So basically, what we'll start with is just looking at the most simple. Let's just look at mod x. What happens in that? So if we start with, it's always nice to start with the graph without the modulus in there. So y equals x just goes like that. You know that. Y equals modulus of x. Y equals x, sorry, that's just y equals x. So what does it look like if we stick the modulus in there? Well, let's have a look at it. If x is positive, then it does nothing to it. In other words, it remains exactly as it is. And if it equals 0, so it goes through there. So if it equals that, what happens if x is negative, so in here, then x becomes negative x. So instead of going down here, this is y equals x here. What we're going to get instead is y equals negative x, which looks like that. So that is actually the graph of y equals mod x. It goes up at 45 degrees, it goes up at 45 degrees there. So that's the graph of y equals x. Good to know. Let's do some stuff with it. Sketching. So jump into an example. Let's have a look at something like this. Okay, so y equals mod x minus 2 mod plus 1. Now there's a couple of ways to do this. I'll do it the slow way, then I'll do it the fast way, and I hope you end up doing it the fast way. So let's have a look at this. We use, just like an equation, let's look at it in the two situations. This, remember, changes behaviour at the point where x is equal to 2. At x equals 2, this thing changes behaviour. If it's bigger than 2, it does something. If it's smaller than 2, it does something else. So we need to look at that. So if x is greater or equal to 2, what does it do? Well, this will be positive if x is greater or equal to 2. So therefore, we get y equals x minus 2 plus 1. In other words, y equals x minus 2 plus 1, x minus 1. So that's what the graph looks like if x is greater or equal to 2. What does it look like if x is less than 2? Then we get y is equal to negative x minus 2, because remember the modulus will times it by negative 1 plus 1. Simplify, y equals negative x, and then that negative, will make that a positive 2 plus 1, positive 3. And so they're the two situations we get on a graph, look like so, and we're looking at the point 2. Again, you won't draw yours like this, you'll have graph paper and do it nice and neatly. So we've got the point 2. If x is greater than 2, what we get is this line x minus 1. So I'll just put minus 1 in here as my y-intercept. X minus 1 goes up through here. I'll draw the entire thing. Maybe I won't. Yeah, I will. X minus 1 looks like this. Yeah, that's not bad. Go me. It's like that. And if x is less than 2, you get negative x plus 3. So I'll just put 3 on here. 1, 2, 3 up here somewhere. And so we'll get the point, the line, x and 3, so it'll go through there. So I'll go something like, I hope I get this sort of roughly right. It's hard with this pen thing, though. It's the setup that I've got going on here. So it looks like, so they're the two graphs. And so if x is greater than 2, we're talking about this line. If x is less than 2, we're talking about this line. And so it ends up looking like that. That's the graph. Y equals mod x minus 2 plus 1. Okay, so that's the slow way. The fast way, x minus 2 plus 1. Fast way is to go, well, this graph is just simply y equals mod x with some translations. It's translated 2 to the right. That's this here. That's telling us it moves 2 to the right. And this is telling us it moves 1 up. And 1 up. And so, really simple. You've got your graph. You know that it's, you know where the x equals 2 is where it changes behaviour, so you can just quickly put 2 onto there, and you know, instead of, I'll just do it quickly, but instead of having y equals mod x there, what it does is that moves 2 to the right, and 1 up. And so what you get is moves 2 across, 1 up, 45 degrees, 45 degrees. If you need to, you can find your y-intercept and that sort of thing. So I'd much prefer you doing it that way, much quicker. If the question asks you to do it the slow way, do it the slow way. But if it doesn't, do it that way. Let's just have a quick look at some more difficult ones. They're not really, they're pretty fun actually. Like, anyway, you won't believe me that they're fun. I'll say it, you won't believe me. Let's just have a look if you get y equals just the modulus of a function. Oops, what happened then? So if you've got something like y with a modulus around the entire function, what does that do to it? Well, basically, if you think about this carefully, if f of x, if the function is greater or equal to 0, then you just get y equals f of x. You've just got the normal function. Nothing happens. But if you've got the function of x is less than 0, then what happens? Then y is equal, you actually flip it, negative f of x. And so what that actually means is it gets flipped in the x-axis only if it's got negative values. So let's just have a look at a quick example of that. Okay, so y is equal to mod x squared minus 3. So I'll firstly just start with drawing the function itself. So x squared minus 3, x squared is up here, minus 3, so you get minus 3 down here. And the function of that, before the modulus, I'll just not doing the modulus yet, comes down here and up like that. So there's our y equals x squared minus 3. So let's just have a think about it. Here, the function is positive, it's above the x-axis, okay? So nothing happens to that. Here, the function is positive, so nothing happens to that either. But in here, this area in here, between here and here, the function is negative. And so what happens to that is we times it by -1. In other words, we change the sign of it. So that means every point in here, instead of being -2 here, it will become +2. This -3 here will become +3. And so this actually gets flipped upside down and reflected in the x-axis. So it ends up looking like, so that bit stays the same, that bit stays the same. And what happens is that this actually gets flipped upside down like that. And so red y equals the modulus of x squared minus 3 looks like that. And if you want to put this point in -3, this point here will be 3. So that's what happens if you get this situation where you've got a modulus around an entire function. The whole function will be above the x-axis because it has to be, because every value is positive. Okay, let's have a look at the only other situation that you need to be aware of, and this is the final thing for mods, is in the situation where you've got y is equal to a function where everything inside, every x in that function has a modulus around it. And again, if you think about it, should I do an example first? I'll do an example, it'll be easier for you to see. But basically, I keep saying one thing and doing the other. What happens is that it doesn't matter whether x is positive or negative, that this function will come out the same. So if you think about that, it doesn't matter if your x value is on this side or this side, it'll be the same thing. So I'll just write it down. But basically what happens in this situation is that it reflects the positive. So all the stuff x greater or equal to 0 on this side reflects that in the y-axis. Okay, so let's just look at an example and it will become apparent to you. So y is equal to 2 to the power modulus x. So let's just again draw a function without the modulus. What does that look like? So 2 to the power x just looks something like this. Okay, that's y equals 2 to the power x. That goes through 1. We've got that. Let's have a think about it. What happens if x is positive? If x is positive, this function looks exactly like that function. So let's just draw that. So if x is positive, we just get that. What happens if x is negative? If x is negative, then it ends up being then just the same as the positive, exactly the same as the positive. And so actually it reflects in the y-axis. So if you say x is equal to 1, so somewhere around here, that'll be the exact same result that you get for 1 will be as if x is equal to negative 1, because it just turns it into being positive, so that'll be that point there. If you go x equals negative 2, that's the same thing as if it was positive 2. So what actually happens is that you just get, oh, that's pretty bad, I'll do that again. Maybe I'll come down from the top, because I was trying to hit that point. You just get this reflection between left and right of the y-axis. And so that red line is y equals 2 modulus x. And that's all we have to do. So there you go, that's modulus. Enjoy.